Hey guys, this is a video showing off my recent project, which is this 72-inch belt sander. A friend wanted one of these, and I had some materials that I thought might make an interesting solution to the problem, and I'm just going to show everybody how I designed it. So we only have two pulleys instead of the several that I've seen on other ones, but that is mainly because of the decision to use these Hiwin linear rails as the main body of the sander. The reason I use these is because I had some old ones that were given to me. The raceways of them are pitted and it's unusable for its original application, but they are still pretty beefy, and I mean the underneath side is still a precision surface even if there's grease on it, so that allows the parts that are mounted on the sander to slide up and down, kind of like for example, the tool rest. I can loosen it and slide it wherever I want it on the sander, and the idler pulley rests or is coupled to this block here, which is free to slide up and down the length of the rails. The way that the rails attach to the motor is via 3D printed a 3D printed coupling, and these 3D printed parts, normally 3D printed parts would not be strong enough for this, in my opinion, but I used a technique where you 3D print a hollow object and fill it in with epoxy granite, which is just sand mixed with epoxy. And this is supposed to be some sort of super material that's a lot of CNC machines are made out of it for its dampening characteristics. It gets rid of vibrations, which is, I would think, pretty awesome in this application. But the way that the rails attach to the motor is with a clamping type mechanism. You can't really see it right now because the pulley's in the way. Let's see, you can almost kind of see it. But here's a printed off part, or a printed view of the CAD model. Just behind the pulley is invisible here, there's a 608 radial bearing that's housed or is recessed inside of this 3D printed part, and this 3D printed part has these two clamshells or things that pinch down on it, and it allows you to rotate the entire assembly down to a horizontal position if you wished. And these 3D printed parts have little lips to keep them aligned with the rails. You can see there. And then underneath of that, this is the rotating part that I just discussed, and underneath of that there is a cloverleaf type shaped standoff. This motor has 4 through bolts, 1, 2, 3, and then 4 down there, but they go all the way through the motor and stick out in the front with a decent amount of thread that I thought that I could utilize to screw into this standoff. And this is also manufactured with the hollow 3D printed parts filled with epoxy granite. This cloverleaf is stood off from the motor itself with these washers to allow air to enter the air intake of the motor, and the exit of that cooling air is also unobstructed. So that's how the rails mount to the motor. The pulleys themselves I made from these caster wheels that I had. They originally had some bearings inside of there, but I pressed them out of it and slapped them in my lathe over here, and you can see that I've turned down the outer surface. I don't know if that was necessary or not, but it helped. I wasn't sure how consistent the molding on those rubber wheels was, and I didn't want to have any vibrations due to that, so I'm pretty happy with it, and the belt seems to ride really well on it. Both of these wheels I balanced on my surface plate, and you can see the holes that I've drilled through them to take away weight in the areas I didn't want it. So underneath of here, I shall take that off real quick. So this is the mechanism that attaches the drive shaft with the drive pulley. This is a 2 3D printed wedge type shaft collars that extend into the pulley itself, and then this hose clamp is used to pull them together and grab a hold of this drive shaft. And then there are 2 screws here that go through this shaft collar and directly into the rubber, making sure that everything, nothing slips. And because this thing rotates pretty quickly, didn't want to have that hose clamp exposed, so I just took this little piece of scrap metal that I had, and voila. Okay, so let's talk about the idler pulley. Focus. This wheel is also balanced. You can see the holes. The shaft in this case is stationary. That was my pulley falling off, don't worry about that. There is a pair of 608 bearings inside of the through hole of this pulley, and this end cap just has a, it's 3D printed, and it has a cotter pin, focus, to prevent it from coming off. And on the other side, there's the same 3D printed part. That one looks, I need to clean that up, but cotter pin as well to hold that on in the back. Now, the tensioning and tracking mechanisms are back here. The tracking is accomplished with this knob. You tighten it or loosen it, and a threaded rod extends down through this, yet again, epoxy granite with 3D printed part. There's a threaded rod that goes down and pushes down on the axle of this idler pulley. And obviously you can see how that would accomplish the tracking. The tensioning is accomplished with this 3D printed epoxy granite part that is bolted into the rails and fixed in place in that manner. And it has a locking knob that when you loosen that lock knob, you can then twist that, and it relieves the tension on this block, which is then free to slide up and down. This idler block assembly, I had to go a little bit off design to get this done or working, but I really like what I ended up with. It's 2 metal plates, just scrap pieces that I had, and on the inner side they are secured to the block with these lock nuts, and you can loosen these to adjust the tension of this jib. It's a 3D printed jib that takes the contour of the inner race of the linear rail, and so you tighten these until this is pressing up against this just enough, and it keeps everything moving in a nice linear manner. Oh, I think, let's see. The next thing is the tool rest. This is a piece of 1/2 inch thick aluminum bar stock that I machined to attach to this piece of aluminum stock. There's a through hole that goes through there. Actually, the rotational part of the tool rest was made from these pieces. I have a ton of these laying around that I got in an auction. They seem to have a through hole and a single machined side, and all of the other surfaces seem to be rough sawn. So what I did was I took them and press fit a piece of round stock into that hole, and used that round stock with my collet block and lined this up so that it was rotationally parallel with all these faces. And I stuck this entire thing into my milling machine and just cleaned up all of those rough sawn surfaces, and you can see all the machining marks on there. This one I kind of tried to sand up a bit, but I'm really happy with how they turned out. The arms of this tool rest are yet again 3D printed with epoxy granite infill. And here's a little bit of a good view of how that looks. The way this works is you loosen both of these knobs and the entire assembly becomes slack, and you can adjust it to whatever angle you want using a whatever tool, measuring tool you have. And once you have it where you want it, you lock both in place. And these things are actually, I mean, this is extremely solid once you get those cranked down. There is some washers to distribute the force and increase the clamping. And I got some Loctite in those holes to prevent that from ever rotating. And let's see. Yeah, I'm definitely going to do some editing with this.